Hello, my name is Steve, and welcome to the Playbook.
And I'm Michael, and the playbook is about the theory of constraints. It's our way of producing products here at Brunson.
And it's important for everyone to really get the theory of constraints. It's going to come up every day, and we need you to understand it, know how to recognize problems, and what to do about them.
First, here's Dighton.
Here at Brunson, we have a complex set of production problems. And this is caused by the fact that we have a low volume, high dollar set of products in our product line. We make stands, we make instruments, we make target holders, we make scaling artifacts, we make all kinds of different things, but we don't make any of them in a very high quantity. Using the theory of constraints helps us with the flow of products through the factory. So we made this video to help you understand what theory of constraints is, and we need you to learn and understand it.
So what is the theory of constraints?
It's a production management approach that focuses on the slowest portion of the production process.
That's a constraint.
Right, the bottleneck, the choke point. So let's hear from Dighton about what this means in a factory situation.
At its core, theory of constraints is very simple. It just says that any process will only be able to operate at the speed of the slowest component. So let's say we have 3 machines, and a part has to go through all 3 machines. We're going to draw 3 funnels to illustrate the 3 processes. And the 3 funnels have different width outputs. The first machine is pretty fast. It can do 20 parts per hour. Those parts go to a second machine, which is a lot slower. It can only do 5 parts per hour. Then those parts go to a third machine, and it's faster again. It can do 15 parts per hour. So if you have all these machines lined up, one after the other, they will only produce parts as a group as fast as the slowest component. So what's going to drop out the bottom after the third machine is only going to be at the rate of 5 parts per hour.
And we can see the constraint sits clearly in the second funnel, where things are backing up.
And that gets messy, and that's not good.
And the important thing for us is not to overrun the constraint, but instead to help expand the width of the funnel at the constraint.
Because if we expand the capacity of the constraint, overall output goes up.
Right, and we get our products out faster and keep our customers happy.
So what you got there?
Reviewing the Brunson product line.
You've got time on your hands?
It's a lot of products.
Right.
So Brunson is not some massive factory that churns out 3,000 or 30,000 items in a run. We are very different from that. We're a small group of talented people, and we make precision products, and we don't run big numbers.
So what does the theory of constraints do?
It keeps us in line, on task, minimizes wasted material and wasted time.
So while we're building a lot of different products and complex production processes,
We can still react quickly, change direction easily, and do everything we can to hit our goals.
the theory of constraints does all that?
If we stick to the playbook, yes.
Okay. So earlier, Dighton talked about keeping the customer happy.
Absolutely. And the customer today is very different than earlier generations.
How so?
Well, today's customer wants the delivery date to be predictable, and they're less willing to wait.
It is an on-demand world.
Yes. And sometimes they ask us to customize our products for them. Brunson has a long history of listening carefully to customers and giving them what they want. So often, engineering has a look at it, new blueprints come down, and we build it to the customer's new specs.
That must increase the complexity in the factory.
It does. And there's another side to the theory of constraints as well.
What's that?
We've got a first-in, first-out system here at Brunson, meaning that we do everything we can to ship the product to the customer in the same sequence that the orders come in. Before the theory of constraints, orders would get pushed aside because we were always reacting to whichever customer was raising hell. And in an environment where everything was late, there were a lot of customers raising hell, so the production flow was in constant turmoil. It was chaotic.
So now with first in, first out,
We have to work out our production challenges right away, and that gets the product out the door. We've averaged as high as 97% for on-time delivery.
and that means happy customers.
And that's why we're here.
So let's take Dighton's funnel example and expand it. Let's say a customer order comes in for 7 units of one of our most popular products. The manufacturing process for this product starts at the saw, goes to the lathe, then the mill, and then assembly. So in this example, the saw, starting the process, can cut 40 parts in an hour for this product, including setup. The lathe can complete 20 an hour. The millwork is more precise and complex. That's 5 per hour. And assembly can do 30 per hour.
But the order was for 7 units?
Exactly. But let's say you're the lathe operator.
Okay, I can knock off 20 parts in an hour on the lathe?
Yes, but how many should you knock off?
This part is for a popular product?
Yeah,
Okay, then I'm going to get it set up, and then I'm going to run like 12 or 14 of these.
that's a common response, but it's wrong. Just run the 7 we need.
But we're going to get more orders. It's a popular product. We'll need this same part next week, or maybe sooner.
Sorry, just run the 7. If you make more, it throws everything off.
But Michael, I run the lathe, and if the lathe isn't making parts, then the boss will notice that. It'll be bad. I look inefficient. If spindles aren't turning, the company isn't making money.
Yeah, I know that's what everybody says, but that's not the whole story.
Okay, that seems crazy.
It can be counterintuitive and challenging to get used to, but when people make more than is called for, it creates chaos.
Chaos?
Yes, we've seen it countless times before. So this is what the theory of constraints tells us. Run just the quantity that's ordered for right now. That's the Brunson playbook.
Okay, but what about my efficiency?
The theory of constraints looks at the bigger picture.
Okay.
Of course, you're supposed to work hard and get your stuff done and done right, but your supervisor is looking at how the overall flow is working. Are we getting the products out on time?
Right.
Sometimes the idea of efficiency means that people want to make more parts to justify the setup time, making each part appear to be less expensive.
And that messes with the overall flow.
Right.
Okay. Don't make extra, and don't worry about your cost per part. One more thing.
Sure.
Let's say I'm working at the constraint.
In our example at the mill, yes, completing 5 parts per hour.
Yeah, so at the mill, I'll be working just to keep up.
Yeah, absolutely. And we're doing everything we can to help you speed up at the constraint, and that might include more hours at your position.
All right, I'm still getting my head around this.
So let's shift and talk more about the 3 big problems that crop up when a machinist runs more than what is ordered.
Okay?
Let's say once again, you're the guy running the lathe.
All right, so I'm not at the constraint, and I have this order for 7 parts.
Yes. So, problem number 1. If you're running the lathe and you make 10 parts instead of the 7 that's called for, that means you're spending more time running the extra parts. That's a problem because in a fast-changing environment like Brunson's, with lots of different products, you need to complete the right quantity, then be on to the next run and the one after that.
So running extra takes time away from the next project.
Yes. It's more time spent on parts we don't need, crowding out the time available to work on the parts we do need.
But what if there's nothing up next for the lathe?
There'll be other things to do. Trust me.
Okay, so what's the second problem?
Problem number 2. The extra parts become an inventory challenge. Who's counting it? How much time someone's spending on inventory management? Where do I keep that overrun? How many do I have?
That sounds like a mess.
Yes, it is. And projected all around the cave, a very costly mess.
Okay, so what's the last one?
Problem number 3. Let's say you made 10 parts instead of the 7 that were needed.
Okay, so there's 3 extra parts.
And then, a week later, engineering calls for a change to that part, a new spec, a new measurement.
So those 3 extra parts are now obsolete. Okay, that's a huge waste.
Yes, of time, money, and materials. So if you imagine everybody overrunning their orders and producing extra parts every time they do a run, it's mayhem.
Let's say I'm the lathe operator with this order for 7 parts. Shouldn't I just run a couple extra so that if something goes wrong downstream, they'll have a part handy?
Well, let me jump in here and make a point.
That's Dighton.
Sometimes people think that they should make extra parts because of something that might happen down the line. But if we do this consistently, we never get to address whatever the real problem is.
And there could be lots of reasons why a part gets scrapped further down the line.
It could be training, it could be programming, it could be the design of the part, it could be the material, it could be a casting, it could be an outside vendor problem. I mean, there's 100 different reasons why something can go wrong like that.
So when you make extra, then we're covering up the downstream problems. We end up making the same mistakes over and over without ever identifying what's wrong. When we know what's wrong, we can fix it.
I get it. Make just the quantity that's ordered.
Yep. The big picture here is that with so many products, getting our orders complete, done right, and out the door is really complex. So what we're doing with the theory of constraints is gaining some control over the process.
And that control starts when we run the right quantity of parts all across the factory.
Our production supervisors are always on the lookout for the constraint. because a bottleneck can sneak in at any point in the production process.
Well, how's that?
Well, with so many different products, the constraint will shift around as conditions and incoming orders change. A new assembly process can shift the constraint there. A new operator on the lathe could make that the constraint. Bottom line is, if there's a bottleneck, your supervisors are working hard to identify and respond to it. This is a complex problem, and our supervisors use tools to locate the constraint when it shifts and then analyze and plan the next steps.
I've got another question, back to the original example. Let's say I'm working the lathe and I'm done with the 7 parts, but then I don't have anything up next. You said there'd be plenty of things to do. Like what?
First, you can practice your setups. Let's say you have a common process and it requires a setup, and that setup takes 45 minutes.
Like, do a setup, even if there's no run.
Exactly. Get creative and find new ways to get faster at them.
So the idea is to shave time off your setups.
Yes. So there's other things you can do as well. You can cross-train and expand your skills.
Seriously, cross-train.
Yeah. If you're trained on another machine, that makes you more valuable and allows us to temporarily move you to an area that needs more help.
Really?
Yes. Learning any new productive skill is time well spent.
Because if we can get more out of the constraint and speed up the slowest part of the process, then the entire process goes faster.
Right. And happy customers.
So, we've got our playbook, and we're on the same page. What can our machinists expect then?
They should understand the basics of the theory of constraints and how it affects their workflow and output.
And what are those basics?
They'll be asked to create set quantities, and probably small quantities, of the parts they're making.
No extras, no overruns.
Right. We've got a first-in, first-out system here at Brunson that, when working with the theory of constraints, gets our products to our customers on time. And we've got a deep catalog. A lot of different products to produce.
Exactly. We're not making thousands of copies of 1 or 2 generic products here.
No, we're not. We're creating small quantities of lots of high-quality, precision products for some very demanding customers.
Who are measuring things very precisely.
Yes, and we're helping them measure, providing the stand, the target, sometimes the measuring device itself to do precise work.
Like?
Assemble the fuselage for a rocket, line up the wicket gates in a hydropower plant, field test their laser trackers, align equipment in a sawmill, put the wing on a new airplane.
All that sounds super precise.
Helping the world measure.
Sounds like a tagline.
That's convenient. And remember, if you have any questions, we are all here to help you.
Thanks for watching.